we look at what is an SNR and what is EB by N naught. So SNR or EB by N naught, it's a key metric, or it's called as a key performance indicator. Okay. So whether it is in SNR is used in the let's say RF domain or any analog domain. Okay. While in digital worlds, it is called as EB by N naught. But the concept is kind of same. Okay. What we are talking about SNR is signal to noise ratio. We're talking about signal and denominator is noise. And here in digital, we are talking about energy within a bit divided by noise. So the concept is same, but the definition is different. And if you remember in the previous slide, I talked about dB. So see, here is an example of a ratio. Okay, this is a ratio, this is a ratio. So ratios you see very commonly used in communication systems. So that's why dB scale is so important. So what is SNR? Signal power to noise power. At a high level, think of it as two ratios of two powers. So if we look at this picture, what that spike, that is the signal in this case, and whatever you see, those small wavy things, those are all the noise. But if I just take like this signal and noise, right? So where does this noise end? This doesn't end. This keeps on going like this. This is like infinite, right? It goes. So where does this end? So we need to define something called as a bandwidth. So you just don't measure signal power and noise power, on an infinite duration. You measure it within this bandwidth. Okay, you take the power within this bandwidth. What is the signal power within the bandwidth? What is the noise power within the bandwidth? And then you take this ratio. Next, what is EB by N naught? In digital domain, we talk about energy per bit over the noise spectral density. So if this is a digital signal, think of these as ones and zeros. Okay, so think of this as 1, this as 0, this is 1, this is 0. Okay, think of ones and zeros. Then what do? I highlight 1 bit here. So you take energy within this 1 bit. Then you take noise within a bandwidth. Okay, how do you define a bandwidth? So not going into too much of details, but there is something called as noise spectral density. Okay, so you have noise like this. Sorry, this is frequency. So you have noise like this, and then you choose a bandwidth. Let's say I choose this as the bandwidth, my FC bandwidth. I take noise within this bandwidth, right? The bandwidth, whatever it is, same bandwidth here, bandwidth. And then I take a ratio. So I take energy within this, all this, and noise within all this. I take a ratio of that. That is EB by N naught. This. So you can also call EB by N naught as SNR per bit. So you're taking 1 bit as the reference. So you can call it as SNR, but it is per bit. So how do you define it per bit? So you are taking SNR, whatever you have this SNR value, right? The same SNR you take here, multiply by the bandwidth, and divide by the data rate. What is data rate? So if you're talking about your internet at home, you're talking about 1 Gbps or whatever, right? So that number, for example. So that is data rate in bits per second. You use that number here. So this will give you SNR per bit, or also called as EB by N. Okay, so we use 1 bit because 1 bit is the lowest, right? That's the smallest thing that you can measure. So data rate is in bits per second. Okay. Please click on like and subscribe to our channel and click on the bell icon for regular updates.